Very good evening to all and welcome to day 5 bootcamp on STAAD Pro. So day 5 we are going to discuss on design. So as I said, day 5 we'll be entering to the design. So we'll be discussing about the design and basic parameters which you want to give for STAAD Pro inputs, and then we'll be seeing some practical sessions how we do it in STAAD Pro, and also some basic formula which you need to know while you use a design, so that will be taken care, right? So to start with day 5, so bootcamp on STAAD Pro day 5 is going to cover on this following topic. So before you go to design, and you need to know about the basic drawings which is highly essential and which are highly important to know about the drawing creations and how the building is going to make a setup. So the most important part of that. So the drawing and the designs, how it is going to be run parallelly, or how it is going to be helpful to give you the concept of design, and how the drawings are helpful in a time being, like how it is going to give some specifications or how it is going to give a certain type of inputs for the designer. So that is a basic thing which we need to know about drawings. So I'll just start with my first part on drawings. So what is the use of drawings and different types of drawings which we are going to discuss today. And then we'll go to the design and further optimizations, how you need to do the optimizations. So there is certain hidden part is there. So I'll be explaining that. And then the last is your report, how you want to prepare a report and you want to submit to the client or some kind of documentations, right? To start with first part, drawings. So here is the types of drawings which you need to understand what is basically a drawing is. So when you talk about drawing, so drawings are basically on 4 types. One is on architecture drawings, then second you go for structural drawings, then we call it as MEP, that is a mechanical, electrical and plumbing drawings, and the next we call it as a management drawings. So quickly we'll see all this part on what are the classification of drawings is going to help you, right? So next part, now how you want to do is, the first part of your drawings, what you're going to see is a drawing, right? So first part which you want to know is, okay, just a minute, let me correct it. My voice is audible. Yes, thank you. Okay. So the first part which you want to know is on drawings is architectural drawing. So what is mainly an architectural drawing? So it is going to show you a layout. So we can say as a layout or a plan to use, which geometry the building is to be prepared. So it will show you a kind of layout or plan, what is the room dimensions, what is the ground area or floor section or elevation view. All this will be show you complete architectural plans. And further that we have a BIM models. So where you use of BIM models, building information models. So today the technology has developed. So where you can travel with the various connection with the various industries. So one can share the file and you can compare with the more models. So we are in the platform of BIM, so where we use various tools of computationals and rendering process and even animations that can help the client to know a walkthrough effect. So starting from the main door, you want to travel inside a house and you want to feel how your building is going to look out. And also the painting, so what kind of painting my walls is to be done, so that can be done, and effective on energy efficiency, how the lighting should be arranged with respect to the sunlight. So all these are certain things where architectural and civil engineering based softwares are doing wonders in that, right? So these are certain models where we discuss on the architectural plans, but our role is majorly on the structural part. So as a civil engineering and the structural engineering, so we need to focus on the design. So what is the design? I'll be explaining you later on what is the use of design. But when you talk about the beam detailing, so how this beam detailing is done and what are the uses, you can see number of colors are representing on the diagrams. So certain size is 12, certain is 16, or certain is showing A, certain is showing as B. So what is this all about? So it's all about the stirrups, the diameter which you are going to use in the main sections or your element of beam, column, slabs, that is your detailing. So when you start rebar connections, when you prepare a rebar connections or some kind of detailing work in beam, so that is called as a beam detailing. So you can see that. And secondly, we have that is called a slab detailing. So where the distribution bars are done for one-way as well as two-way slabs. So when you talk about one-way and two-way slabs, so we have number of numerical discussed in the textbooks. So what is the design we have done? So number of cases for two-way slabs, and we do for reinforcement details. So these are certain idea where you see from the textbooks. So the textbook will show one single diagram or single section. But when you go to the field of industry, you get a proper plan. What is this particular plan? So in the textbooks, what happened? You do only this part. So you might be studied only this part in the textbook. So you might be seeing that there is certain case where you have to know about your cases. So two edge continuous, two long edge discontinuous. So you might be studied about the cases. But when you come to field, so you have number of beams here. So and number of slabs are resting over there. So you want to think about the cases, which cases I want to adapt for this beam, or sorry, this slab. What is the case number for this slab? What is the case number for this slabs? So I need to think about, and then I need to start doing the designs for this. So this is one showing you the slab detailing. The third is your column detailing. So where you see a column building. So on the third day I said a column grouping. So if you have 1,000 plus columns, so we are not going to do the design for 1,000 plus columns, as I said earlier. So we are going to use the technique called grouping. So that's what I taught you, that idea, why we need to do the groupings. So when you do the groupings, you can see this column IDs, C1, C2, C3, or C4 till C7. So certain columns with certain detailing is done over here. So this into mark shows that the columns are not projected further. So it is end over here. So it is closed here. So no further continuation of columns are there. So this is a guidelines how you need to do the column detailing with the proper inputs. Now this is a part of management. So where you go for management level. So how these management drawings are helpful for making your drawings. So they also have certain drawings that is called OBS, organizational breakdown structures, and work breakdown structures, and the schedules. What are the day-to-day schedules as happening? So they do the day-to-day schedules. So they have some kind of organization chart or work chart or schedule chart to be printed out, and they see the level of activities, what is completed. So one is going to go for the field of management field. So then definitely it is a part to understand the Primavera and your MSP software. So how to handle the inputs for the field of management part, right? Further that, we also have something called MEP, that is called MEP, mechanical, electrical and plumbing part. So this deals purely on your mechanical part, that is a shaft or ventilation or AC duct or firefighting devices which you want to install in your building. And same way for electrical circuits, some kind of electrical circuits which you want to plan for your buildings, power generators or electrical circuits or lighting systems or ventilation, again for all this part will be taken care. And plumbing, we know that for water services. So where you need a water services, so we can go for plumbing diagrams also. So all this will show you a guidelines and number of software, yes, especially the Rivet. So when you talk about the Rivet, so we have this number of inputs in the Rivets and based off of BIM based software. Right. So further that, what we are going to do in a design. So coming to back to our part. So design. So what is a design basically? So design is common word. So the design is a common word where every field has a word called design. So let it be a car manufacturing company. So they also have a design. So they want to prepare a new model of car for this 2021. So they plan and design. So what our car should be when compared to the last year, what is the new features in our car, or what is updation in our car module. So this is the one kind of design we can say. Or even a single teacup. When you go for a paper cup or teacup, they also have a design. So what is the diameter of your cup? What is the height of your cup? What is the material it should be there? So this is also called a design. And even your bridges, then going for bridge design or house. So everywhere we have a connection of a word design. But what a common connection when I come to my part of experience. What is a design? So design is nothing but a big story or big concept where you want to study for a whole day or like something. The thing is, you want to understand certain basic things which is highly essential to make a perfect design. So that is the main major important focus what this design is all about. On that basis, so I can say a design is nothing but it can be any geometry, it can be any shape, any geometry, any size. So geometry includes your shape and size, your shape and your size. Let it be any circular building or a rectangular building, whatever the shape, whatever the sizes. Let us say G+1 or G+10. So whatever it is. So it is nothing but it is connected to the height only. So let us say whatever the geometry, whatever the height or size. The next important parameter is your loads. So what kind of load you are going to distribute to the buildings, or a car model, what kind of load is going to be taken care by the car designs or buildings. So what is the load? Important parameter is your load. So first thing, you should understand the load. So how you are going to calculate the loads. So that is the basic steps. So if you are able to calculate the right calculations of load, then 100% your building is stable enough. You might be seeing a person in the exhibition used to walk on the rope, you on both sides. So from one end to the other end, the small people used to walk on this part. So how it is possible? So they have the technique to balance their load balance on this particular rope. So that also comes as a practice and the technique how they balance the body weight on this particular rope. So same way when you talk about our part, so the ground is here, how you want to make a stable building on this particular ground. So what kind of load is distributed to this ground? Either my building is safe enough or not when later load is coming, acting on my building, or some kind of earthquake is coming. So my building is safe against that or not. So these are the techniques how you learn the load concept and how you incorporate the loads in the buildings. Then coming parallelly to the next part is the most important part, that is a material. So when you talk about the materials, it's nothing but only a concrete and steel. We can simply say a concrete and steel as a basic parameter right now. So let us forget about the other materials, that is a steel composite materials, forget about all that fibers, whatever it is. So basically focusing on two material, concrete and steel. What is the grade of concrete you are going to use? What is the grade of steel you are going to use? So some may use 450, some may use 500, or some may use M20, some may use M25. So for which particular load the concrete grade is suitable, so that you should connect. So this load I can go for this kind of material. Or apart from concrete or steel, now come for other alternative materials. You have PVCs, you have glass, you have number of fibers. So these are some kind of new innovations in the material, how to make a lightweight structures in the building also, right? So that are the other parameters which you want to think on the design, basically are based on the materials. The next is testings. So testing is based purely on the software. So you can go with any kind of software modules where you are going to do the testings. So I can't test manually whole night a G+12 building. I cannot do a manual design for all columns and all beams of G+12 story building whole night to do it manually. So what I do, I need a kind of computational tools as a help to test my idea is correct or not. So for testing, I call for softwares like STAAD Pro, ANSYS, Abacus, or some kind of Revit. So we call the software for making our model and to complete the test by all these inputs. So what are the inputs you are going to give? So that can be happen and you can do the testing in the software. Once your test is passed, all the data is within the limitation of safe limit, then you go for the construction. But when you run the model and you find some kind of alert or warnings or failure patterns, then we go back again, we call what is the mistake in the loads, or what is the geometry should be modified, or what is the material should be modified, and then again we repeat the test until you get a right limitation of passing criteria. So until you get a successful criteria, we do the iteration process. So right, so this is the process of design, how you need to do it. So don't try to understand that with single go or with single iteration, I can say that suppose a 12 kilonewton load is safe enough for carrying for 300 by 375 mm beam. I can't say this. I can't say this, right? So it is not that with a conclusion that I can say this 300 by 375 mm size beam is sufficient to carry 12 kilonewton load. So it depends on the material what the user is going to give. It depends on the length. What is the length of this member? It is 12 meter or 6 meter or 3 meter, depends on that. So all these are the criteria how you do this in a model in softwares, right? So moving further to the design, so basically we need only this criteria, that is a concrete and the steel criteria. What are the inputs you are going to give in the design? That is going to design your design parameters in the STAAD Pro, right? So quickly seeing on that part, so next is your optimizations. So what comes in optimization? Now the question is optimization. So why we need optimization after doing a design? So first parameter is your cost. So nobody don't like a cost, right? So if your huge cost is there, so nobody's go for that contracting or go for the constructions, right? So we need economical aspects, right? So that is the cost is required. And second thing, economical design. So that economical designs cover already the cost and the quality. So this two will be covered under the optimizations. So how this optimization is based on cost and quality is how you make a section designed properly. So what kind of iteration level you do. So practice with the different types of load patterns. You come to know, yes, previous model I have done on this part, I got a safe limit. So why not to go second project with the same model? Loads are different. Okay, so this size is not suitable for this particular load. So I redefined my size. So I come to know for a certain set. So this size is suitable for this particular range of frequencies. So for example, like a 12 kilonewton to say suppose 100 kilonewton, I can say all the sizes of beams are suppose 232 cross 375 or suppose 300 cross 450. All this will be safe enough. Just an example, right? So more than 100 kilonewton. So suppose I say 150 kilonewton to 275 kilonewtons. So I'm going to handle a second project. In my second project, I'm getting extra loads. So which is previous project I handle a maximum 100 kilonewton. But in the second project, I'm going to go for 150 to 275. So when you do the project, when you do the practice or when you start the work, so you come to know this size or already I have used up to 100 kilonewton, it shows safe. So let us try one more combination. So let's go for different combinations. So let us start with 375 by 500 mm. Give a try. Okay, this is safe. It is showing, the software is showing safe. Then slightly change it. So 350 cross 425. So let's try. Warning or error is coming. So this size is not suitable. So my minimum size will be 375 will be my minimum size. So I come to idea of optimizations. So this comes in the practice only how you do the optimization technology, right? So next is, here is an option for you. So on the screen, you can see some options where you see some kind of a TV shown to you. So now my question is here. So how many of you go for, let us put the numbers on the screen, then you can give your answer on the chat box in the meantime, quickly. 1, 2, 3, and 4, 5, 6. So let's give a number only. You can just enter the number in meantime. So which TV you like to choose? Which TV you like to choose? You can give your numbers in the chat box quickly. So I have 6 TVs on in front of the screen. So you can give your numbers quickly. So one goes for 6. Okay, Hussein gives 6. Suraj again 3. Gaurav 5. Okay. Vishwanath 4. Then Agarwal. Yes, fine. Pranesh, Yuvraj, Hanif, F. Yeah, right. So all have different options, right? So nobody is able to stick to certain case. So everybody is given a random number now. So everybody has given a random number now. So where is optimization here? Can anyone say where is the optimization? So where is the optimization here? So there is no optimization here, right? So everybody give a different opinion. So everybody is giving different opinion, but basically it is a TV. You agree to my answer? It is a TV. It's nothing else. It is not going to speak, or it is not going to dance with you, or it is not going to make some kind of additional robotic works. It is a TV which is making on electronic based, but yes, there is some kind of additional features with the rates. So as you go for higher rates, there are certain features built in. So everything is basically a TV only. In the old model also we have a TV. Nowadays the very slim size, where you see a very minute slim size is there. So people are like to purchase this kind of slim TV and hang it on the wall, and that shows a good appearance also. So basically everything is a TV only here. So like that we have everything is a building. Now according to this picture, everything is a building. So either it is a bridge building, either it is a library building, either it is an office building, either it is a school building, it is a building. Now second thing which you want to know is the design. So now the design. So every TV is a design of a rectangular box. You can see every TV is a rectangular box. In nowadays we have a foldable TVs where we can see, we can fold the sections of the TV. You can completely fold the TV and we can keep it in a corner. When you need, you want to open stretch the screens, and you can go for it. The technologies are coming right now in the market. So these are the design. Now it comes as a design for you. Now second thing is optimizations. As we discussed about the optimizations. Now what is optimization lying here is first is on cost, as I discussed on the topic cost. So if your customer want a budget between 20,000 only, okay, so he goes for this particular TV. If a customer is having 30,000 in his hand, he need a good TV. Yes, he can go for this basket. If a customer is having a budget of 40,000, so he can go for it. Or 1 lakh, yes, you can go for it. So the optimization say everything should be safely designed. Everything should be safely designed, but the geometry where you have like a 5-star hotel where you have a very plenty amount of space. So you have very wide area of garden, wide foundations, or your rooms, or your aesthetical room design, your what is that restaurant. So everything is very fantastic. So the rent for that building, or when you go and stay there, it will be very costly. So this is how the buildings depends on the geometry. The optimization should be brought. So the connection here is based on your geometry first, as we discussed already. So it is based on your geometry. First, it starts with your geometry. So in a structural building, the plan, floor size, what is the room size, all that is your geometry. Second, the load. What is the load you're going to give to the building? So that depends on your part. So what are the loads? As I said, this is a simple example. So depend on that, the optimization of the size will vary. Right. Now coming to the cost, yes, we have different options, but the features are varying here little bit. So this is a simple example of electronic based. So where we have different options, smart TVs are selling in the market. So in a building, when you talk about a structural analysis, what is the optimization in structural method? So it is a computer method of designing an engineering system, because they are having a more number of results. So alternative options, if this beam is having a safe, why not other size? So my question here is, when your size of beam, when the size of beam is safe enough, at 230 by 300 mm, why you are giving a size of 300 by 375 mm in the software? So when you understand this principle, then you can make optimizations. So when your beam is safe enough for this particular size, why you want to go for 300 by 375? Not necessary at all. So you are wasting the concrete, you are wasting the rebars, everything is wasted there. So this is called optimizations. So it comes through regular practice once you start with the project. So the structural optimization is a numerical optimization techniques that deals with your materials and design, and to make a cost effective manner. So my definition on optimization is, you cannot understand the optimization until you are having a practice and experience in the modeling of a structure. So take some project and do some residential buildings. You try to come across various sizes. So once you come across various sizes of beam, then you have an idea of optimizations. Then you move to the second project. Suddenly you come to strike in your mind, yes, this size is suitable for this particular load. So 50 tons or whatever the kilonewtons. Yes, I have an idea about it. So this comes in regular practice, right? So I'm just holding on here. Now I'm going to show you something that is in a STAAD Pro, how the designs are carried out, right? So moving further to the STAAD Pro. So what we are going to do in STAAD Pro, so we are going to design a beam today. So with the beam with certain loads, so what are the ways you need to do the design? So I have shared the material here. Later on I'll share to you. Right, so let's go to the design parameters. So this is the design parameters which you are going to see in STAAD Pro. And once you select the design parameters, you need to design that inputs. So where you want to give the certain inputs to the parameters, and then you need to command the concrete of beam or column or slab, all these things. And the most important thing is your takeoff. When you give some kind of quantities of steel or quantities of concrete, you can get it out from the takeoff value. So you can give that command and it will show your quantities finally, right? And further that, this is a second method that is called as advanced RCC method. So rather than showing here, I'm just sharing my screen right now. Just hold on for a minute. Okay, I hope the screen is visible now. Right. So I think this is designed. Okay, yeah, fine. So this is a one sample building where we have designed this completely. And here you can see this answers where the concrete designs are coming. So when you run the models, so once you click on the beam, you can see the concrete design. So a number of students ask me one doubt here. So this is correct or not? What are the bar size it is showing? It is correct or not? If you are asking this question, it is correct or not, right? Then you have a big doubt in the software. So that's all is making correct or not. So our role is here is to check either here it is higher or lower. So the bars which is showing on the screen, you can see 1, 2, 3, 4, 5 bars on the top and 2 bars on the top bottom. So you are questioning this is right or wrong. So this depends once you start the detailing work. And how the detailing work goes is once you open the output file and then go down, you can see this RCC design. So here is your focus is required. So you need to see this size, this cover, this length. What is the AST value of getting? So that should be seen. That I think the screen is not visible due to the output file. Let me do it. So here you can see this part. So when you click on this part, the concrete design, where you see this. So go to the output file, click on the output file. This was I was saying now, discussing this. So what is the grade you are using? What is the size? What is the length? And what is the cover you have used? And see this AST value. So this AST value is satisfying your bar size, then it is okay. Now you see here 7 bars of 10 mm, 2 layers are used. So when you go for a detailed RCC, it will take another 1-2 hour lectures on this part. So 2 layers, what is this 2 layer? Here it is 1 layer, again 2 layer. So when you see the RCC building bar binders, so they used to put second layer in the beam casting. So when you see that second layer, there are certain additional rebars they are giving. And in the middle portion, if you see about this length, middle portion, 1 layer is running, that to 2 bars of 10 mm dia is running. So these are the design you need to see in detail about that. And what are the spacing they are using? So this you studied in the RCC subject, how you want to design a beam. So there you might be studied a singly reinforced, doubly reinforced. But when you come and see in the software, it will not show you singly reinforced or doubly reinforced. It will show only a basic result, AST, the moment, the spacing. Our role is to check that AST is sufficient, the shear force is traveling through that beam is safe limit or not. So if shear is failing, then you get more number of cracks and you need to take care of your stirrup spacings. So these are the major role of structural designer when you go ahead. Similarly, when come down here, you can see the columns. You can see for the columns. Same way we can see for columns also. So column numbers. So it shows your column numbers. What is the total area? What is the total concrete? And what are the reinforcements? So you might be studied about 4% is the maximum PT limit. So all this will be shown here. And also your moment about biaxial moment. Moment 1, moment 2, biaxial moments. So that can be shown here. And all this will be shown for the column also. As I said already, the slab is not possible in STAAD Pro. For slab, we will take to Connect Edition. So slab detailing is possible in Connect Edition. So you get full details of slab, what are the spacing, everything you will be getting there. And finally, this is a takeoff. I have not given takeoff, I guess. Let me check. Yeah, here is no takeoff command. Right. So going back to the design. So let's start a new part quickly. I will tell you the tricks how to start a design. So let me take a simple example, beam design. So I'm proceeding with that. So what you can do here, suppose I have a beam of 5 meter. So I'm just taking a 5 meter span. Then I'm going to the supports. I'm going to give a fixed supports over there. I'm just giving 2 fixed here, 1 and 1, right? And then you can go to the property. Now roughly you take any size, whatever the size you like to give. You give your size 300 by 230. I'm just giving 300 by 230. Add that. Now what we are going to do, I'm going to do the loadings. Go to the loading and click on load case. You can add a dead load. Right? And then click on self weight, then add some member loads. So let us take minus 13.1, add that. So just click on this beam, assign to the selected beams, and then select this again. Okay, so this is done from my side, right? So most important thing is just you can focus on the labels. Right click, labels. You can click on labels to adjust this part. So learn some shortcut tricks. So all keys are very helpful for you. So you please go through it. So when you use some kind of shift plus V, the value will not shown here. You can use switch off that. So if when you need a values, shift plus V can be used. Beam numbers, shift plus B, or beam orientation, shift plus O, a dimension, shift plus D. So these are certain shortcuts key. You can use it later on. Now click on the scales, click on apply, and you can adjust this point distribution force. So you can see this when you adjust that. So automatically when you some of the students say, sir, I applied the load, on the screen the load is not visible. So please go through this scale, right click, and you can apply tick mark on apply immediately. Just try to adjust that. So automatically it will show you on the screens. Right. So this is done. Now we are going to check either all things is done. So let's check that missing attributes. Okay. Right. Now I'm just going to give the static check. Right. Analyze. So it is going to run the analysis and it's going to give the file. Now coming to the design. So please note down the design can be done in 3 parameters. 3 different ways. First way is your automatic design. First is your automatic design by the software. So we don't want to give any inputs. We don't want to give any single input. The software will automatically run and it will give you. But it is suggested that it is not to be used always, and it is wrong when you go for industry. Because in industry we are not going to depend blindly on the software. We are going to depend on the designer. So whatever the designer is going to give the inputs, that should be done by the software. So if everything is done by the software, then no use of the structural engineer or civil engineer. So first thing I'll show you that. Click on the design and go to the concrete. I have given the steps in notes, don't worry. And click on your code book, IS 456. So for different countries, we have a number of codes. So click on IS 456 for Indian. And then don't need to click the select parameters or define parameters. Directly jump to the command. You can directly go to the command. So I'm just skipping this first two steps. I'm going to command. Just click on add beam. I'm not going to give a takeoff right now. So just I'm going to design this beam. Click on that. You should use this selected beams. So when you have 600 beams, so use grouping. So what are the groups you are using? So you need to use some grouping. So with that method, you can also do it. So select this beam, assign it. So it is assigned. You saw a green color tick mark. Now run the analysis and then go to post-process. Apply. Now use a beam cursor. You see the concrete design there. You get your concrete design. And even when you go to your output file, your design is ready there. You can get your output file from here, concrete design. It's ready there. So you can see 340, 125 mm again, 164 mm square, all these values you got. Right. So this is the size C. M30 it is taken. It has taken 25 mm cover, 415 AST FE bar is 415 and size is taken by this. So this is 2 leg stirrups, 8 mm dia is used. So this is automatic design. So this is the automatic design. So let's come back to this part. So let us delete that results. So I'm going to delete that result. Delete. So now normal part. So now the second method which we are going to do is select parameters. So which parameter I want to select? So here are around 22 to 25 parameters are available. So what you need to select here? So what type of parameter you are going to select? So for that concrete, select the code, then select the parameters. So here you can see one by one parameters. So what all things is required? Suppose I need a clear cover. What is my clear cover? I'll select that. Suppose my grade is changing, M35 or M40 grade or M10 grade. So I can select that grade of concrete. Or FE500 I want to use, then I can select that. Or secondary reinforcements which I want to use, so I can select that. So like this we can select each and every inputs what is required to be designed. So this is highly useful when you studied RCC subject. Then you can come for this part. So you should understand parallelly with the RCC subject, what is spacing, what is the reinforcement percentage level, PT level, all this will be over here. So let us take this basically these 4 parameters and then I'm just closing it. Now whatever the parameters are selected, it will be reflecting in define. So you can see that 4 parameters only. So clear cover, what are the clear cover I need? So I need to type the what is the clear cover I should use. So I'm just giving 25 here. So I'll add that. Then what is your grade of concrete should be used? So here this kilonewton should be mentioned here. So suppose I'm going to use M20. So 000 for thousands. Yeah. Then FE or 500 I'm going to use 1, 2, 3. Right. So like this we need to keep on adding your inputs what you're going to give for your design. Now I have done that. So let's go for selected beam, assign, and then assign this also. Do slowly everything to the selected beam. Don't give to assign to view. What happens when you assign to view is when you have a model, complicated models or some columns, by default you'll give assign to view for all the structures. So you go for a mistake. So when you have a beam element, select the particular beam, give the particular inputs. If you have a column, then select the particular inputs for the column. Example, when you have a beam, for beams you have some grade M25 grade to be poured, or columns from 5th level to 7th level, you have a higher grade M30 or M35 should be poured. So you need to select that accordingly with the section view or grouping method. Then you select the parameters assigned to that. So since here is 1 parameters, I'm just selecting it and then giving all this part. Right. So this is done. Now what I'm going to do, I'm just after giving this input, without that if you run it will not design. So what you want to do, so let's see, I'll show the error also. So I'm just given this. Without giving this, what happens? I'll show you a sample. So when I run this, go to the output, it will not show you anything. So you see there. So no concrete design comes there. So you'll see this is blank. So you'll not get your output file ready. So in order to do that, so go back. So once your inputs are done to this part, right, so this is done. So add your command that design this beam. So click this. Now assign. Yes. Now run the model. Sorry, I guess I missed one parameter. Let's see. It missed it. Wait. So please do it. Let me do the corrections. Okay, fine. So let's do that. Go to design. So select your parameters. Okay, now just define it. Okay, select it again. Yes. 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 Right. Now give the command. Assign. Yes. Right. So now run the analysis. Now you can check, go to the post-processing. Now you can see your design. Again, it's ready. So when you go and see the output file, what are the inputs you are given? So it will be showing your inputs. What inputs you are given? M25 grade I have chosen. F5 I have 415. The spacing, everything will be changing here. So this event, so what size of bar I want to use, I can define it. So this is a second method of designing in your STAAD Pro. Now coming to the third method that is called as advanced Rcc method. So you want to go for this advanced level. So I'll just show you here what we need to do. Once you're done with the analysis part, so here is a concrete design tab. You can click on this part. Just click on this part. So it will take you to the advanced Rcc designer. The steps I have already provided in your PPT materials. I will share that. Don't worry. The first thing which you want to create an envelope. So envelope is a job inputs. What you want to do. So I want to do design of this beam. So I should give an envelope to this. So select that and give an envelope. So suppose I want to say beam. So I want to give a name. Right. Click OK. And it will ask you the load, where the loads are available. So show combination and select that and drop it on this part. Click OK now. So the load is assigned to this beam. So if you're not doing that step, you will not get a design. It will show 0 loads are assigned to the structure. So assign the loads to the structure. So first step is envelope. Second step is group and brief. Once you go to the group and brief, now you are going to explain what type of beam it is. So what is the grade should be used? What is the input grade of steel should be used? What is the spacing should be done? Or design for torsion should be done. Design for shear should be designed. So all this inputs is going to come over here. So again, you can select that and you can give it on a brief. First give the brief, then go to group. So click on brief. Again, give some beam number or what are the beam number 1. Let me give a different name. Here you select your code as you saw the previous one, IS 456. Then select the beam or column. It will ask you two parameters. Either you want to design RCC member only. As I said, slabs cannot be done here. So only beam and column. So beam, click OK. Now you can see the similar interface. What grade you want to choose. Up to M40 can be done here. Right? And then main reinforcements, what is the size of bar you can use? You can give it over here. So suppose I say 12. So I'm going to give a 12, maximum size as 25. I'm just going to give I close here. So 12 and 25, I'm going to prefer it. Then bar, let it be FE415, minimum size 10. Okay, for this is side bars. So let it be 10. Shear reinforcements, what are you want to do shear reinforcements? All this part you can invert, add this and click OK now. The next part which you want to do is a grouping. So you want to design a grouping. So grouping can be done in two ways. One is directly you can click here. It will show you a previous brief ID. So B1, or what you can do, select this. You can go to the members, select this beam, right click, click this with member, and you can give a form member. So you want to give a form members, you can give the member ID. So once you give this form member, it will take you to design group. So it will go for group. So you want to assign this to group. So what is group now? So you have some 25 members or 25 beams. Some members will be similar size, as I said already. Some beam size will be similar. So you need to give up member IDs to that. So that is called form members. So you need to define the members ID first, basically. And then now let's create a group for this. So I need to get our group members. So click that, design a new group, right click on it, design a new group. So give that group ID. So it will be assigned there. Now once it is done, click on members. Then you can select this and go to your design. So concrete members design, design now. So you can click on design. Now you can see on the screen, it shows fail. It shows fail now. So I'm going to design now. So once I design, it shows okay, okay, fine. Now you can see all the details, inputs, what is this coming over here, where the rebars are going to cut. You can see this cut bars, and where is the shear reinforcements is coming, and your schedule of bars you can export to DXF file, the detailing of your drawings. You want to see it in A2, A4, you want to see a preview, all can be done over here. And then the most important part is this part. So this table, the summary table, just let me, main reinforcements, this table. So this is the most important table you want to understand. So what is the size of bar I have given? I have given 12 as minimum, maximum as 25. So the software will say that 16 is more than sufficient. For this particular load, 16 mm dia is more than sufficient. Now you can work out 2 bars of 16. What is the AST? What is your small AST value? So that will explain you what is the AST obtained on the screen, right? So that is your final part. So let's go back. So here it shows that what is your AST value. So 2 bars of 16. What is that answer? Whatever the AMF is coming here, the capital AST should be satisfied that. So you get that answer over there. So whenever this AST is higher, then we can replace this with certain number of bars. So I can go for 20, then I can change for 22 or 25, then I can increase it. So the layer which you saw, that second layer, so that is nothing but, this is called the layer. So when you see in a cut section, so this is your top fiber and this is your bottom fiber. So normally what we have seen, this is a normal part where everybody have studied this. The beam carries 4 bars, uniform bars, 2 bars on top, 2 bars at bottom. Now when the AST is increased, we increase 3 bars or 2 bars at the bottom. The second layer is here. Now this is called as second layer. So top, second layer, bottom, single layer. So this is your rebars. Now bottom also have 2 layers, suppose in heavy sections, heavy reinforcement. So you have bottom also second layers. So when you project this in a 3D, what happens? So this is how you project in 3D. So when you see a bar benders are making a bar schedules, you see these bars. So 3 bars will be running. Suppose these bars will be running throughout. This will be running throughout the section. So this will be running throughout the section. This is an extra bar. So this will be binded here. So it will be looped here. The same way on other side, so up to certain case. So where you see this cut portion, that is your change in reinforcements. So where the cut element, this is called as cut element, where you make a bend in the bar. So that is called cut elements. Then we make a stirrups, we type with the stirrups, and we take care of the stirrups spacings, and middle we have a stirrup spacings. So like this we'll make a design. And bottom, suppose 2 bars are running throughout, so 2 bars will be running throughout. So this is what we do in RCC design, what you see in the CAD diagram, the draftsman used to do it, right? So that's what we do it finally, and we get your designs on the screen. So you can see these diagrams also. So how this bars is exported to DXF file, you can open and see in your drawings. So that completes your RCC design. So now whatever the size of bars, so as I said already, so whatever the size you are going to use, so my suggestion for you is now this is a house, sample house. So you need to do the grouping. Suppose this column and these columns are same size, you can do the grouping. Suppose the internal column is different size, so start grouping. So try to change the group. So you put this in separate group. So for example, this might be lesser size. Just I'm giving an example. So it might not be, right? So this will be different size. This will be in different size, exterior columns, interior columns. So in such case, you use this grouping so that will help you out to make much more easier. So whenever you select the groupings, so your beams and columns can be done. So the same way, the roof beams where you want to select, you can group that. Then completely you do the design. So you get your product out as a final report. The last topic is a report. So how to prepare a report. So here you can see some camera. So take picture. So you can take this picture and can save wherever you want to take a picture. You can take a sample picture. So you can give numbers or a name, then add all this part. So after analyzing, you want to go to post-processing. Then you want to see the reactions or some displacement. I want to take a printout of this. So you can take a snapshot, bending moment. So you can add all these details. Now once you're done with this, what you do, you go to the report setting, setup of reports. So click on that. So what you want to do, so print that as a PDF or Word document, whatever the size you want to do it, you can do the setting. Now after that, you want to go for this report setup. What all things you want to do. So I want to know about my number of beams or number of materials or support. So these are the inputs which you have something like called. Then load case details. If you have load case details, you can add all the load case details over here, already added. Then design. So when you go for design inputs, you can add design inputs. Then all design inputs is added here. Then go for picture. So you have taken 2 pictures, right? So you can add these 2 pictures also. So what are the pictures you are going to add? You can change here pictures, 2 pictures, add that also. Output file, the designs where we have some designs, summary, reactions. Then advanced steel design reports. No report is there for me. Okay, I have not done. Then earthquake reports. So floor eccentricity, all like these things. So whatever you are done with this reports, once you're done with, click OK. Then you can open your Word document, export to Word document. So once you click on Word document, it will ask you where you want save. So click save. And then go to the settings where you have the settings. You just open that file. And there is that Word document. It gets open there. Exported here, right? Okay, just a minute. Let me open Word. Where I've exported. Okay, open, sorry. Now it get open. You can see that it prepares a report completely, right? So, but necessarily we will not do this part. So only it is required, we'll go for the report generation, or else manual templates we have in Office. We go for that manual templates. What are the details we want to fill? we'll put it and do it. But number of students in the classes or college level, they do this and they submit as an assignment, but it is not highly appreciable for the students. Okay, just you can learn the techniques, but when you work with proper way, try to understand and do it. So don't do simply for page numbers, you do this and give us a thesis or a report, case study report. It's not that. So what you have studied, apply properly, right? So these are the topics which we are discussed in day 5. I'm just coming back to my meeting. Yes. Okay. So moving further. So here you can see a detailed part how you want to see this full structure, how we are going to do it, various parameters, how we are doing this analysis. So each and every step-by-step procedure I have mentioned here, you can go and see this, load, then we added it, then what are the inputs you want to do, the groupings, give the name, then click OK, then proceed with the alternative methods, how you can do this, right click, give select members and design groups, then add your inputs, then go for design now, and then you finally get your table. So please remember this table, and then your design should be completed. So that's what day 5 on design topics, how we concluded, right? So any questions, we'll go for question sessions at the last. So this completes your day 5 topics on design aspects. So that's what we completed for the day 5 with all your inputs, your optimizations and reports, drawing and section and your design parts. Okay, so let me stop it up to here and come back to the meeting and we'll take a question sessions. Right. So any questions for the day? So let me start with the questions in meantime. Okay, FC grade I've added. Okay, for that. Okay. Okay, definitely I'll share the sessions material, don't worry. Value of engineering and optimization is different. See, both have concept of your cost. So what is your value of engineering is basically on the cost parameters. So wherever you make a product, you want to attract the customers, right? So if your product is very costly, no customers will come to you. So that is a market value, right? So same way, the size here, it is purely based on the safety limit, what size you are going to choose for a building. So in a case of dam, if I'm going to construct a dam, I can't say that a dam is sufficient with 230 mm size by 300 mm size beam. So it's a blind to say that. It's a foolish thing to say that. So we should not come to the conclusion like that. So what is the geometry? So only I again say, what is the geometry? What is the size? And what is the load? So this is the basic parameter you should understand. So then you can go ahead for the design. Right. So next question, what is your nature of support of beam and column junction? Fixed. Naturally, we'll go for fixed supports. And then yes, any other questions? How much we do a member failed? So yes, how we come to know the members are failed is once you go and see in the detail shear reinforcement, it will show over shear. It will show over shear. So that particular section is failed. And there are also size where the optimization can like some kind of warnings will be there. Number of warnings for that particular beam ID will be reflecting on your screen. From that, we can find out the section is failing there. Right. Then Zain has at some time in one floor different size of beam shown, but which is not aesthetic views good. See, actually different size of beam is depend on the designer. So suppose the designer wants to reduce the beam size inside a house. In your hall, if you think in your hall, so huge size of beams are there. So you want to know about that huge size beam is occupying your room. So what you do, ultimately size basically, right? So that you want to reduce the size by modeling only. So what size you want to modify the beam, then you can modify it, right? So next question. Okay, don't have the first and second. It is already shared. Please check your email. I have shared it. For circular beam design, it is recommended to draw a small straight beam instead of using curved beam command. Kindly comment on about that statement. Yes, Yuvraj, for that, what is the issue is Actually, in a circular beam, we can't do proper detailing there. So it is highly complicated for a circular beam. So when you have a proper segment of lines, so you can make some kind of plate elements, as I showed already on the previous part, that is a circular beam. Rather than drawing a number of polygonal meshings, so you can go for a proper square meshings in a plate design or surface element. So for that purpose, rather than drawing a curved members, you can draw imaginary dummy beams, and then we can do the meshing part. So that can help you in your models. So that is your question. A circular beam is designed, recommended a small straight beams. So that's the part. For that, we need to do again a grid calculation where your beams should be coincide with the circular beam head. Okay, right. So next question, Hussein again. Okay, then. It is necessary to do design in STAAD Pro if we are going to do design in Rcc Designer. No need. If you're going to design an advanced Rcc Designer, you don't want to do in our STAAD Pro model. You can, your entire model is shifted to the advanced Rcc Designer. So no need to do there. Even in STAAD Connect Edition, it's very good. More than that, it is very easy for in STAAD Connect Editions. Right. So what will be the criteria for both design method 2 and method 3? Method 3 is more right and abrupt manner, I can say. Method 3 is you get all your detailing drawings, all your detailed sections, everything is very good over third method rather than the second method. So I prefer basically to go to the third method in advanced Rcc Designer. That can help you out to good results. Yes, I tried many times with proper inputs and everything, but I never get a concrete takeoff. Okay, what is the problem? Okay. So takeoff, if you're not giving properly inputs, so you face a problem there. So you should give a proper takeoff. I will show you at the end. I got your questions. I'll solve your issue. Johnson, your takeoff issues are coming, right? I'll tell you that. Okay. Please tell me about the AST table, which is AST approved. Okay, provider or AST required. Okay, fine. I'll tell you that. Then which method will more effective for design method? Third method, as I already said, third method will be much better. Beam column capacity ratio in STAAD Pro can we obtain? There is a ratio for slenderness only. Beam column capacity ratio we don't have. For slenderness checking, we can do that. Once your design parameters inputs you're giving, we get your ratios there. How to find demand capacity ratio of beam and a column in software or manual? Demand capacity ratio of beam is not possible or not getting here. Only thing we are getting only slenderness ratio. What is your, as you see in the column, you can get that, and buckling class we can check it out. If you're using some kind of a steel structure, there we can see some kind of steel buckling classes. So that can use through a steel code. So that can be helpful in steel design. Okay, fine. We can design inclined beam in STAAD Pro. Yes, we can do inclined design in STAAD Pro, same manner as I showed the skew angle, rotation, we can do that. Okay, please share some models of structural analysis. Okay, fine, sure. Okay, so before going at, so let us all take a small group photo over here. I request if you are possible to open your camera, I can show you some kind of symbol. So happy learnings. So okay, I'll share you. Here's what is the difference between Connect Edition and normal V8i. See, Connect Edition has a various part of sharing a file from Revit models or from kind of BIM models, even a EcoSim software that is a BIM model. EcoSim is a Bentley product. So you can work parallelly and you can shift from one system to another system by file transforming. So it shows the realistic and the graphical interface is much more there. And suppose you are working in one model, you are in USA and I'm in Germany or some other person in India. So we are working on some project. So rather than putting in Google Drive, I want to download here. So I make a Connect Edition. So what you do, I call all my the engineers to work on that model on the spot. So it's kind of file sharing is much better and easy. So you can log in your company portal and you can start working on the project. So that is called Connect Editions. Basically, it is very good advanced level.
So, sir, we get all the features that we normally get in our normal STAAD Pro.
More than that. More than that.
Oh, yeah, and we get something extra.
Yes, yes. as I said, slab design is more easier there in Connect Edition. So we'll just take a photo and then we'll come back with group sessions. If everybody liking to open your camera, we can open and we can have some final day click for this workshop. Okay, I hope you have enjoyed the session. It was useful. Anyone can give you a comment on the session, how it was. I'm getting your feedback daily. I'm reading your comments. Sometimes they are saying very fast. I agree, due to the time constraint, I'm very fast in teaching. So that is my habit. Don't worry, I'm always supporting you. So anyone? Just one.
Should we talk or drop the message?
You can talk just one word.
Sir, it was an excellent training session, and actually we demand if you further time arrange any session like e-tabs or a Tekla model software base, then it will be very beneficial for us, sir. Thank you. Thank you, sir.
Thank you, Zain. Right. So,
sir,
yes.
Sir, can you please send first, second, and third class PDF notes? It will
Okay, sure. Definitely, I will. I think I already mailed you.
I only get the fourth class.
One. Okay, fine. I'll share you it again. Don't worry. Okay, so let's go for a screen click. Ready? 1, 2, 3. Again, one more. 1, 2, 3. Okay, so I hope all have enjoyed it. Thank you. So meet you next workshop in coming days. So tomorrow will be a last quiz round. So be at proper time, 4 o'clock. It will be started, and maximum it will take 4 to 15 minutes duration, or 20 minutes duration, and the sessions will be completed by 4:30. Okay. All the best. Go through all the materials and all the software interface that what we have discussed for so far. Okay. So meet you tomorrow. Thank you. Signing out.
Okay, sir. Thank you, sir. Anyway, sir, this sessions has been, sir, very good. I would really like to thank you, sir.
Thank you for your
level of details touched. Yes, sir.
Thank you for all the participants from various colleges and universities who have taken part. And yes, I'm happy to see my old pass out students also here in this session. So happy for joining them also, right? So all the best, and meet you tomorrow for next session. Thank you.